Hello guys, welcome to OKONKWO Academy. This is the third lecture on probability and statistics, and under this we are going to treat probability of an event. We will talk about some basic concepts on probability, we will solve some questions, and I'll move on into the additional law or addition law in probability. So to begin with, if you are new to this channel, I recommend that you subscribe and put us on post notification so that you'll be notified whenever we upload a video. Now, what is probability? So probability is the likelihood that an event will occur, right? So it is assigned a weight. So the probability that an event will occur is assigned values between 0 to 1. So let's say we have an event A, right? An event A, and let's say we have a total experiment, the total outcome of an experiment, and this experiment is the tossing of a die, right? So with the tossing of a die, we know that the sample space is 1 to 6, and let's say A is the event where we are looking for the even numbers of this toss. So the even numbers of this toss, that's A, which is that event. So when we are asked to find the probability of this event, we have to know the number of outcomes of this event. In this case, we have 3 outcomes that are possible. That this is the number of possible outcomes of this event. So 3. And we have to know the total number of outcome of the event on its own. Sorry, the sample space on its own. So for that one, it is 6. So the number of outcomes of the event A is 3, and the number of outcomes of the sample space is 6. So the probability of that event A is the number of outcomes of A divided by the number of sample space. Then we get 3 over 6. Then we get what? 0.5. So let's move on to this condition. I've said that the probability of an event lies from 0 to 1. It can never be less than 0, or it can never be greater than 0. In the worst case scenario, it can be 0, and in some scenarios too, it can be 1. When the probability of an event is 1, then it means that that event will happen. I want you to take note of this, because when we are done, we are going to read these statements. So I'll explain some things, these statements. So when the probability of an event, let's say E, is equal to 1, then the event will occur. So when that probability is close to 1, then the event is likely to occur. But when it is close to 0, then the event is not really likely to occur. There's a low chance that it will occur. And when it is 0, when the probability of the event is 0, then it means that the event will not occur. The event will not occur. So we should take note of this. Now, we've heard of these statements, and it has been used most of the time in our daily routines. So let's look at this. John will probably win the tennis match. So this is telling us about the chance that John can win this match, right? Then another one is, I have 50-50 chance of getting an even number when I toss a die. So this is also telling us that there is a 50 chance that we can get an even number, and there's also a 50% chance that we would not get an even number. And the rest of the examples talk about the probability and chances of an event. Now, let's move on into another thing. So another concept that I would want us to take note is that for us to get the probability of an event, right, we can sum the probability of the elements in that event. So sometimes it's not all the time that we can use the number of events. Sometimes we are given the probability that the elements in that event will occur. So if you want to know the probability of the whole event, we just sum the probabilities of the individual elements to get the probability of the whole event, right? So let's say we have an event A, right, with elements A1, A2, A3, AN, right? Then the probability of A1 is, let's say, x1, probability of A2 is x2, probability of A3 is x3, probability of AN is equal to xn, right? What we do is that for us to get probability of A, it's just the summation of probability of A1, probability of A2, probability of A3, then probability of AN. That's it. That's it. So this is another concept that I wanted to share with you guys. Now let's move on into an example so that we get to understand this concept better. So let's say with this question, it starts like this. A statistics class for engineers consists of 25 industrial, right? 25 industrial. So number of industrial is 25. 10 mechanical. So 10 mechanical. 10 electrical. Then for civil we have 8 engineering students. If a person is randomly selected by the instructor to answer a question, find the probability that the student choosing is A, an industrial engineering major, right? First of all, who are we dealing with? We are dealing with engineering students. So the total sample space is the summation of all the students because they are all engineering students before we come and get the divisions with their various majors. So the total sample space, I'll name it S, will be equal to 25 plus 10 plus 10 plus 8. So this is going to give 25 plus 28. Then so 28 plus 25 is going to give us 53. Right. So this is the total sample space. Then the question is asking us to find the probability that the student choosing is an industrial engineering major. So as I said, probability of an event, in this case the event is the industrial engineering major, is equal to the number of outcomes of that event divided by the number of outcomes of the sample space. Now this is the number of outcomes of the sample space, which is 53. That is 53 engineering students. And the number of industrial engineering students that could be available for selection is 25. So the probability of selecting an industrial engineer, right, or an industrial engineering student is the number of industrial engineering students divided by the number of engineering students, right? So we are going to get 25 over 53 as our probability. Now the next question is for us to find the probability of selecting a civil engineer or an electrical engineer. Now this is where I'll show you a particular trick in probability. I've always said that math is not really English, right? You just need to know some terms so that you can be able to solve every question. Now if you hear or, right, or both, let's let's use this term, or both. It means that you are doing union. If you hear end, it means you are doing intersection. So now, if this question was like, find the probability that the student chosen is a civil engineering student and an electrical engineering student, like what you are supposed to find is civil intersection electrical. But because they are saying that a civil engineering student or an electrical engineering student, then what we are finding is C union E. So this is what we are finding. So with that, what you are going to do is to find the number of civil engineering students plus the number of electrical engineering students, because it is union. Union is sum, right? Divided by the number of engineering students. So the number of civil engineering students is what? 8, and the number of electrical engineering students is 10. So 8 plus 10, all divided by 53. Then you get 18 over 53 as our final answer. So I hope you understand up to this point. Now let's move on into the addition rule. So with the addition rule, I'm going to use addition rule of probability. Now probability. Now we use the addition rule to solve the last question as well. But before that, I'm going to use Venn diagram to explain the addition rule for us. And I hope we got it in our first 2 lectures, how to get the notations of the Venn diagram, or how to get the regions with the notations. Okay, so let's name this event A and this event B, right? Let's say we are asked to find the probability that A or B might occur, right? So that means that you are asked to find probability of A union B, right? Yes. So with that, what we have to find, right? We can do this. So we can go this way. Probability that A or B will occur, right? As a summation thing. So we can find the probability that A would occur, right? Plus probability that B would occur minus probability that A and B will occur. Why that? Why that? So I've already said that probability of an event is the number of outcomes of that event divided by the number of sample space, and we know that, right? And the number of outcomes of A and B can be number of outcomes of A plus number of outcomes of B, all divided by number of outcomes of this. Now let's see something here. I want to prove this for you to really understand. So for this, the probability of A and B will be equal to this plus. Now let's look at something here. So you see this Venn diagram, right? This circle intersects with this, right? So if I'd want us to see this shaded portion comes in just once, right? So it falls in this circle and also falls in this circle. So if we use the number of outcomes of B, we have all this circle with us. Let me use another pen. So the number of outcomes of B has all this circle with us, and the number of outcomes of A, also has all this circle with us as well. So this portion appears 2 times. That portion appears 2 times, and this portion is no other than A intersection B, right? So for that, we would have to remove 1 from it, because when we just write this, it means that this portion has appeared in it 2 times, right? Because we have something like this, right? Something like this. So, and something like this. So if I write the number of outcomes of A, this part falls inside. So if I write the number of outcomes of A, it involves region 1 and region 2. And if I write the number of outcomes of B, and let's say this one is 3. So if I write the number of outcomes of B, it also involves 2 and 3 as well. So it's like we have, let's say this region. So for NA, we have 1 plus 2. And for NB, we have 2 plus 3. So you see, 2 is inside 2 times, right? Region 2 is inside 2 times. So with that, we need to remove 1. That's why we would have to subtract. So let's say I want to get the probability. It's going to be 1 plus 2 plus 2 plus 3, right? So 2 has appeared 2 times. So what we do is that we subtract 1, 2 from it. One of the 2's from it, we subtract from it. So with this one is represented by N of A, and this is represented by N of B, right? But this is represented by N of A intersection B. Do you get it? So this boils down to this point. So with this, we have to subtract N of A intersection B, all divided by the sample space from it as well. Then we come and get our final addition rule, which is P of A, because the probability of A is the number of outcomes of A divided by the number of sample space, plus probability of B minus probability of A intersection B.